Hi everyone, let's go over this problem here. It says the rectangular loop is shown in the figure uh, into the magnetic field which points inwards. So we're pushing this little rectangular loop into this magnetic field. Let me just pull up a whiteboard quick. So let's talk about this. So I'm going to draw it in a 2D kind of shape where here is our little rectangle. Here's our magnetic field going like this. We'll call this B. And as we move this little rectangle coil thing into the magnetic field, we move it with some velocity, let's say this way, it's going to hit more field lines. And the way that we can best describe this is that the amount of field lines that we're hitting per unit time increases as we get closer and closer into the magnetic field. Now, if we know that this is not just a two-dimensional thing, but this is really a rectangle like this. I know that's a bad drawing, but bear with me. And we know that thus the flux is increasing, or the amount of field lines through an area. Now, if we go back to the problem, it wants us to know what is the direction of the induced current. And to do this, let's just do a very simple Lenz's law analysis. Well, if the amount of field lines is increasing, the amount of flux is increasing, and the amount of flux is increasing in this way. So we call this the delta, or the change in flux of magnetic field lines. But Lenz's law says that any generated current here, any generated current that we get is not going to follow a typical right-hand rule as if we went with the change in flux vector direction. We need to say there's an induced field this way, and that's what we take the right-hand rule with. So take your right-hand rule, point your thumb in the direction of the induced magnetic field, and you're going to see that your fingers are going to curl in this way, and I can draw that like this, okay? And I guess it doesn't say where to look. Let's see, rectangular loop. What is the direction of the induced current? So in this case, we're looking from this direction. Okay, so the observer is looking. That's a very weird eye. Let me draw that eyeball a little bigger. It's looking down this way. So if we kind of look that way, this is going to be counterclockwise. Sorry, it's a little weird to see, so let's say counterclockwise. And yep, that's going to be the answer for this one. I hope you guys enjoyed. Drop a like, comment, and subscribe. Have a wonderful day. Bye-bye.